Alright, so Unit 4, Lesson 2 deals with making a table. Yesterday you saw how to plot points and ordered pairs on a graph. Today we're making a table, and then tomorrow we're basically putting it all together to create an equation, to create a line from an equation. Alright, so our objective for today is to learn how to make a table of values when an equation has two variables. Okay? The two variables will be referred to a whole bunch of different ways. For example, first of all, we'll refer to them as x and y values most commonly when we go to plot them. Okay? But we'll also refer to them as inputs or a domain or a range and output. Okay? So input, output, x, y, domain, range. Alright? These are all different terms that we use for the same thing. Okay? Looking at example 1, we're asked to make a table for the equation y equals 3x plus 5. Okay, now a couple of quick things to note here. Alright, something we've learned already is slope-intercept form is y equals mx plus b, where y is by itself, and then here's our x, here's our b. We haven't really used this for much, we just kept solving for y in the previous chapter. Alright, we're going to start to see an importance for that as we progress through these videos. Alright, so we're asked to make a table. Alright, and what we're going to do is we're going to select some values for the x, the domain. Okay, and pretty easily we're going to set up the table, and I'm going to choose three values, and it really doesn't matter which three we use. Alright, what I'm going to do is I'm going to be consistent and use these three values, alright, on the type of problem that we have right now. Okay, and the reason why I'm choosing those is because we know the biggest problem we have is with signs. So by choosing a negative and a positive, alright, what I'm doing is I'm forcing a sign mistake to come out if I do happen to make a mistake. Alright, and then of course 1 and 0 are easy to work with, so that's why we use it. Alright, so what I'm going to do is I chose my x values, I'm going to plug them into the equation, alright, and then I'm going to calculate. 3 times negative 1 is negative 3, plus 5 is 2. Alright, I'm going to plug 0 in. 3 times 0 is 0, plus 5 is 5. And then I plug 1 in. 3 times 1 is 3, plus 5 is 8. And what we end up with are three ordered pairs, negative 1 and 2, 0 and 5, and 1 and 8. Okay? So again, it doesn't matter what you choose for the x values, alright? Whatever you plug in, though, it's going to dictate what the y value is. That's why we call this an input and an output. Alright? You get to choose what you put into a formula, and whatever you put in is going to dictate what comes out. Alright, let's move on to B. Again, same situation here. Okay? I'm going to make a table, and I'm going to choose negative 1, 0, and 1 as my values. Alright, I'm going to plug my number in. And I'm going to be really careful here to make sure I use parentheses. Negative times a negative is a positive. 2 times 1 is 2. Minus 4 is negative 2. Put my 0 in. Negative 2 times 0 minus 4. That's 0 minus 4, which is negative 4. And then lastly, we put the 1 in. That's negative 2 minus 4, which is negative 6. So again, I'm given three sets of ordered pairs here when I'm done. I'm going to make sure I write those out. Alright, example C we're going to do in class tomorrow, so skip that for now. Let's move on to example 2. Now you'll notice example 2 looks just like example 1. It's telling us to make a table. But what's different now is I have fractions, alright, in front of the x. And how this makes the problem different is I want to be a little bit smarter with what I choose for my x value. Now again, you could choose anything you want. You guys have calculators, so you could go ahead and do this. But graphing decimals and fractions becomes more estimating than accuracy, so we want to make sure we're accurate when we do this. Alright, so what I'm going to do, instead of negative 1, 0, 1, I'm going to choose negative 3, 0, 3. And the reason why I chose negative 3, 0, 3 is because of that number right there. Okay? And the reason why this works so nice is what happens when I plug negative 3 in, is I end up with a 3 on top and a 3 on the bottom. And when I multiply fractions, I could cancel, cross cancel there, and that becomes negative 2 plus 5, which is 3. So I don't have to deal with the fractions if I choose my numbers correctly. 0 always works, because 0 is always going to wipe out this piece anyways, and I'm left with 5. Alright, and then the last one, again, we put a 3 in there. Alright, because we wanted those to cancel out, and I end up with 2 plus 5, which is 7. Now, something I want to highlight before I move on here. Alright, notice that when I canceled out the 3, I didn't lose the negative sign that was originally there. Alright, so 3 goes into negative 3 negative 1 times, so we have that negative there, which is still there with the 2 when I multiply. And don't lose your negatives. Okay? And then again, I have 3 points, negative 3, 3, 0, 5, and 3, 7. Alright, let's move on to B. Again, same situation here. I'm asked to make a table. And I see that fraction. So once again, I'm going to make a wise decision here. Instead of doing negative 1, 0, 1, I'm going to look at the denominator of that fraction. Okay, and I am going to choose negative 5, 0, and 5. Alright, once again, I'm taking what the denominator is. Alright, and I'm going to make it negative and positive. So I plug that in, and the whole purpose of that, once again, is so that these cancel. Don't forget that this should be negative 1. And 2 times negative 1 is negative 2 minus 5. That'll get me in negative 7. Alright, continue on. Put 0 in. Anything times 0 is 0. That's a negative 5. Be careful with your signs there. And then the last one. So basically what this is each problem is 3 little mini order of operations problems. Alright, that we worked with first semester. Alright, so in doing that, we have our points negative 5, negative 7, 0, negative 5, and 5, negative 3. Okay? And just like we said in the previous one, leave C for right now. You'll do that in class tomorrow. Let's move on to the last one. Okay? The last set of examples here, you'll notice are a little bit different than example 1 and example 2. Alright? In example 1 and example 2, we had y equals, y equals, y equals, y equals. Alright? We get down to here, we don't have that y equals. Now we have 2 choices. And I'll show you one choice for A and one choice for B. Alright? The first choice is we could solve this thing for y. And we're pretty good at this from all the practice we got last unit. Okay, so I would subtract 2x from both sides. That would get me 3y equal to negative 2x plus 6. Then divide by 3. So I end up with y equaling negative 2/3 x plus 2. Okay, then I can make my table. And notice I have a fraction. So once again, I'm going to make sure I choose wisely. I want to do negative 3, 0, and 3. Plug it in. Negative 2/3 times negative 3 plus 2. Negative times negative is positive. Maybe you want to do your signs first. The 3's cancel, so I have 2 plus 2, which is 4. When I put 0 in, that's just going to wipe that out and give me 2. Shouldn't have to show work on that. Alright, and then the last one, let me plug my 3 in. The 2's cancel. Negative 2 plus 2 is 0. Okay? So that's one way of doing this problem when y is not by itself. The other way of doing the problem is you could go straight to the table. Alright, it's just going to require a little bit more work. Now, I don't know what to choose because there's y is not by itself. I don't know if there'll be a fraction or not. So I'm going to do negative 1, 0, 1. And again, I plug it in for x. And now I have to solve this equation. So plus 1 from both sides. That's 6. Divide by negative 1. That should be an equal sign. Divide by negative 1. And we get y equals negative 6. Okay? Then we got to do it again. Put 0 in. Alright, we don't need to subtract 0, but we do have to divide by negative 1, so I get a negative 5. Then we put 1 in, subtract 1 from each side, and then we have to divide by -1. So we get a -4 here. Okay, I think it's a lot easier if you look at this. I had to do the same exact solving 3 different times. If you solve it first, you only have to do it once, and then it's just order of operations, and it goes much quicker. So I prefer it if you did this method here. Solve for y, alright, and then make your table. However, either one will get you right answers. Alright, it's just a matter of which one's faster. Okay, so that's how you make a table, and tomorrow we'll see in a video using that table to actually graph a line. See you in class tomorrow.